Hi, welcome back to the vlog.
Okay, let's talk about 6.3. 6.3 is dealing with triangles and their circumcenter. Okay? We will spend time on this tomorrow also in class. So let's talk. Circumcenter, okay? A point of concurrency when bisectors meet a single point. So the point of concurrency is when bisectors meet a single point. So what we're gonna do is, we talked about angle bisectors yesterday in triangles. We're gonna create all the angle bisectors, and when they meet in the middle, or on the outside, or wherever they meet in the triangle, or around the triangle, that is the point of concurrency. So it's where all of the bisectors meet. Concurrent segments, or concurrent rays, or concurrent lines. All three are interchangeable. Concurrent segments, rays, lines, okay? They're the bisectors. They're what bisects the other things. So you can bisect with a ray, a line, or a segment. Okay. I'm sorry, just write it. No, go ahead, switch it. Concurrent segments, so concurrent segments, concurrent rays, or concurrent lines are the actual bisectors that create the point of concurrency, that meet to create the point of concurrency. Oh, this is gonna take a lot of thinking.
I do circles in chemistry, and that's a lot of thinking.
Okay, now can I switch it?
Yes, you can.
Okay, concurrency and perpendicular bisectors theorem. The perpendicular bisectors of a triangle intersect at a point which is the same distance from the triangle's vertices. So, segment DE, segment DF, and segment DG are perpendicular bisectors. So they created perpendicular bisectors here, here, and here. The point where they meet at, okay, creates lines from the vertex, or from all the vertices, that are equal distance. So if you have perpendicular bisectors, the point where they meet can be drawn to each vertice to create equal congruent segments. So DA, DB, and DC all become congruent. And then I have lots of triangles going on in that picture. So you first use the perpendicular bisectors of a triangle. Where they meet is called the point of concurrency. That point, from that point, you can then draw other lines off of it to the vertices, to the vertex, and those are equal.
So they're all equal
From vertex to the point of concurrency from the perpendicular bisectors.
Did you have like apple something?
And Christmas tea.
pumpkin spice.
Isn't it called like apple cider? Did you have apple cider around Thanksgiving? That just sounds disgusting.
Can you, even though they're getting off topic, can
Let's
you
see.
please put this in?
Let's see.
Sorry, thank you.
You're very welcome.
Okay, so, that might sound confusing, and I understand that, and it is confusing. We're gonna just have to work through it and keep practicing. So when you have perpendicular bisectors, they meet at a point called the point of concurrency. At that point of concurrency, you can draw lines to each vertice. Point of concurrency to the vertices. Those vertices, those lines drawn from the vertice to the point of concurrency are all congruent. Okay. So it looks different in different types of triangles. Okay? The perpendicular bisector of a triangle intersects at a point which is the same distance from the triangle's vertices. That's what we just talked about. Okay? That's just a different look. So here are the perpendicular bisectors. They all meet that point of concurrency. They draw a line out to each vertex. and those lines are congruent. Now, it looks different depending on what type of triangle you have. If you have an acute triangle, the point of concurrency is in the middle of the triangle. If you have a right triangle, it's going to meet on the hypotenuse someplace. If you have an obtuse triangle, it is on the outside. Yes, this is why it gets confusing, okay?
What's it called?
It's not, it's called the point of concurrency, okay? It's the circumcenter, the point of concurrency. Okay, so here's why. With an acute triangle, if I do a perpendicular bisector right here, right? Perpendicular bisector, it then creates that point inside. But on a right triangle, when you do a perpendicular bisector, because of how it's created, the perpendicular bisector of this line goes straight through there. The perpendicular bisector of this line goes straight through there, okay? Perpendicular bisector of this line comes diagonally through here, okay? And that's why they meet on this hypotenuse. Over here, this line's perpendicular bisector is coming this way. This line's perpendicular bisector is coming this way. And this part of the triangle, its perpendicular bisector slants down. So they meet on the outside because of the obtuse angle. Okay, so this takes a lot of looking at things and getting familiar with pictures and ideas. Okay. So, below, 3 perpendicular bisectors create a point of concurrency. The point of concurrency is associated, or is located at 7, 4, and is a distance of 13 from the vertices. Okay, so this is located at 7, 4, and they're saying it's 13 to each vertex. Okay, the length is. One of the vertices has an x-coordinate of 12. If this vertex is located in the first quadrant, what is the vertex's y-coordinate?
So would we start with the distance formula?
So would you do the distance formula? No, I know the distance. The distance is 13.
So then,
You could do the distance formula, but you're not gonna have certain pieces of it that you're used to having. You're gonna have different pieces. So if I know the distance is 13, right? Usually I'm trying to find what is the distance. But if I know the distance, that means I have what it's equal to, correct?
yes.
So I can say 13 equals what?
X sub 2.
So x1, 7, and minus 12 squared, right?
Yeah, and then
Plus 4 minus y squared. Okay, so technically, yes, I can use the distance formula. You have to be able to work this backwards. What's the first step to work that backwards? How do you get rid of a square root?
you have to, yeah,
Square. So square both sides of the equation. What's 13 squared? Is it 269? 169? Okay, so you get 169 equals 7 minus 12 squared plus 4 minus y squared, right? What do you do from there? What do you do from there?
inside the front. What do you do the square bracket?
7 minus 4.
Okay, what's 7 minus 12?
5.
And negative 5 squared is? So I can at least simplify some stuff. I can say 169 equals 25, and then I have 4 minus y times 4 minus y. So you have to do what? It's not called distributing.
We have to like
F, O, R, L.
First, outer, inside,
Okay, so 169 equals 25 plus 16, what's this, negative 4y negative 4y squared. Yes? Oh, yay. From here, see, this is back to algebra, you guys should be excited, yes? Okay, so from here, you get, let's combine like terms and put this in standard form. 169 equals y squared, negative 8y. What is 16 plus 25?
31.
How about 40?
41. That's what I meant.
And then subtract 169 from both sides. You get 0 equals y squared minus 8y. What's 41 minus 169? What? Thank you, it is a negative number, negative 128. Now, what do you have to do from there? What do you have to do from there?
Factor.
Factor. Good thing the leading coefficient is 1. What multiplies to give me negative 128, adds to give me negative 8?
4 times 5 out 1 equals 1.
What multiplies to give me negative 128, but adds to give me negative 8?
It has to have a minus and a plus.
It does have to have a minus or plus. Good. Can, what, 128?
8 and 16.
8 and 16? Okay. 8 and 16. Negative, positive. Because when you do 8 times 16, you get negative 128. When you do negative 16 plus 8, you get negative 8y. Okay, so then I have to say y can equal what? Y can equal either negative 8 or positive 16. But the original problem says, what is the y coordinate if it's in the first quadrant? So 16. And that's how I would know what it is. So the answer should be 12, 16. So you have to work the distance formula backwards sometimes. Okay? Okay. Oh, good. Okay. Okay, so circumcenter, okay, is a point of concurrency that is equal distant from each of its vertices. Okay? A circumcenter is a point of concurrency that is equal distant from each of its vertices. Okay? We can circumscribe a circle around a polygon and the circumcenter. Okay, so when you circumscribe something, it is placing a circle around a polygon and the circumcenter or the point of concurrency, which is the center of the circle. So when you find the circumcenter or the point of concurrency, that is the center of the circle, which is then allows you to draw a circle around that shape. I know. That's why I said we're spending 2 days on this. Yeah? Okay. So study these vocab words tonight, write them out for me, because they are going to get confusing. Because in 6.4, we're gonna learn more that goes with this same thing, and the words are very similar, inscribe and things like that. So you need to have definitions memorized, okay? So study these for me. Okay, it says calculate the graph of the circumcenter of the given triangle. And it shows us this triangle has a vertex at negative 4, 4, negative 4, 0, and 6, 0, okay? And it wants us to calculate, and graph the circumcenter of the given triangle. Okay, calculate and graph it. What do you think we need to figure out? Yes, and yes, sort of. What what type of triangle is this? So where's it going to meet at?
The hypotenuse.
On the hypotenuse, okay? So that gives you a visual of something that it's supposed to look like. That's good, okay? So here's what you're gonna do to solve these type of equations. You're going to first start with the midpoint of the vertical segment, okay? You gotta find the midpoint of the vertical segment, which is, that's a good question. So the midpoint of the vertical segment, y midpoint equals y1 plus y2 over 2. So y1 plus y2 over 2. So I'm gonna find the midpoint of this segment right here. Okay, so 0 plus 4 over 2 would give me, I'm taking the y midpoint. Okay, the y midpoint would be 0 plus 4 over 2, which gives you 2, okay? So that point, because this segment both has -4 for the x, okay? My point becomes -4, 2. Okay, -4, 2. Then you have to find the midpoint of the horizontal segment, okay? When you're doing the vertical segment, you're finding the midpoint of y. When you're doing the horizontal, what do you think you're finding the midpoint of? X. Of x, okay? So, here's the horizontal, yes, these two right here. So how do I find the midpoint of that horizontal? So -4 plus 6 over 2, which would equal 1. So my point would be, okay, so I have 1. So my point would be 1, 0, because my y's are the same here, yes? Okay. And then, okay, so you can use your perpendicular bisector to locate the circumcenter of the triangle. The bisector passes through the midpoint. So if I have 1, 0, and -4, 2, okay?
If we do the midpoint formula of those two, would that be our midpoint?
So -4, 2 is gonna be like here, yes? It would be like, from here would be the bisector. Okay. 1, 0 is going to be like -4, 3, 2, 1, 0, 1, like here. So you'd have your perpendicular bisector go through here, okay? And then you have one more side to do, right? Technically speaking, you would have a perpendicular bisector that falls through the midpoint of that line there. So you would find the midpoint formula.
Why would you have one that's lines?
You have 3 midpoints of each, you have a midpoint of each line. So this one you actually have to do math with, because you have the midpoint would equal, midpoint of the diagonal. Okay, you would have to actually set up and do, 6 plus -4 over 2, and you would have to do 4 plus 0 over 2. And you would get your solution of, 6 minus 4 is 2, 1 over, or 1 and 2. Okay, so then you would draw that through 1, 2. And that's where your circumcenter is. This is exactly how you graph it. So you're finding the midpoints of all 3 of the segments. And since it's a right triangle, it should have ended on that hypotenuse, yes? Okay, so when you do it, you're basically just finding the midpoint of all 3 lines. When they say the midpoint of the vertical, they're just making you do less work, okay? Because the x is the same on the vertical, so it doesn't matter that you do the x, it's that number. Okay, because -4 and -4 added together is -8, divided by 2 is -4. I don't have to show that math, okay? So when you're finding the midpoints, those are the points where it would go through, and you can draw from there using a straight edge to your vertice, okay? From your vertice through that point creates your perpendicular bisector things that's gonna happen. just on the one angle that's the right angle. The other two, it's just your straight up perpendicular bisector. And that's how you find the circumcenter. Okay, so we are done, and we're gonna work on homework. Tomorrow we'll work on more homework on the same thing.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Maya?
That was